Okay, students, we will start off with the module 3, that is embedded system components. In this module, we are going to study the various components required for building the embedded system. So let us go through the quickly the syllabus of this module. First, we are going to study what is embedded system and the general computing system, classification of embedded systems, major applications and purpose of the embedded system, core of an embedded system, including all types of the processors and controllers. So here we are going to study various components of the embedded system. So let us see the definition of the embedded system. An embedded system is electronic electromechanical system designed to perform a specific function and is a combination of both hardware and the firmware. Firmware is also called as software. So here, so here, so if you compare the embedded system and the normal system, so normal computing system or a general purpose computing system is alterable, whereas in embedded system, firmware of the embedded system is pre-programmed and not alterable. Performs the key deciding factor. Performance is the key deciding factor in the selection of the system, and the requirement is faster and better. So here, application specific or the key deciding factor means in a general purpose computing system, what happens is we can directly means we can have all the components. Like example is your desktop computer system. In desktop computer system, we can install any software and we can work with any type of interfaces. Means components means we can use your desktop system for any purpose. Whereas in application, your embedded system is application specific. If we manufacture an embedded system for example, for ticket printing machine in the bus, we can't use that to print a that is the bill in your shopping malls. Means application specific is the main feature of the embedded system. Means design and hardware cannot be altered, so less or not tailored towards the reduced operating power requirements. So on a general purpose system, that is the left side is the features of general purpose systems and right side is the features of the embedded system. So here in general purpose system, there is a huge amount of power availability, whereas in case of embedded system, the power availability is very less. So as I already told, if we consider a desktop computers which are connected within the your home, so where the power availability from the KEB or your power mains is always available. Whereas in case of embedded system, for example, ticket printing machine in the bus, so which has to be traveled, bus will travel for hundreds of kilometers, for which the power is to be retained by the system. So next is response requirements is not critical in general purpose systems. Means responsiveness is not much having a importance. So there is no much importance to the responsiveness. Whereas in embedded system, uh, so like that is here responsiveness is very important. It has to, its response must be correct and also within a time. Example is missile system. So I will give one example to each. So here what happens is, if you consider your desktop computer in which you are browsing a, you will browse for particular website. If website is not reached, you will browse again. Okay, you can enter the link and you can press enter key. You may get. Okay, that will not cause any disaster. If you consider any missile dropping system, okay, in a aircraft, if missile is dropped slightly later, it may hit the citizens, that causes the uh, that is the damage like that. So the embedded systems are time critical. So next, here the general purpose systems need not be deterministic, whereas embedded system must be deterministic. Means further embedded systems are classified as a real-time systems. So in real-time system, its response time as well as its correctness must be correct. Okay, like for example, they are further classified as soft real-time systems and hard real-time systems. In hard real-time system, response time should be very much correct. Otherwise, it is not said to be the hard real-time system. So that is a comparison between the general purpose embedded system, general purpose system and the embedded system. So next, we have a classification of embedded systems. Embedded systems can be classified based on the generation as first generation, second generation, and third generation and fourth generation embedded systems. So initially, the embedded systems uses the very smaller microcontrollers, microprocessors called as 8-bit microcontrollers like 8085, 8086, 16-bit microcontroller. So that is called as first generation embedded systems. Usually calculators are called as first generation embedded system. Second generation embedded system used the 16-bit microprocessors and microcontrollers, and third generation used 32-bit processors and application specific integrated circuits. Fourth generation used the system on chip and reconfigurable integrated circuits. The advancement in the processor and microcontroller technology has led to these different generations. As the generation increased, the memory capacity, the processor used, the interfaces used, IO devices used also as advanced and resulted in different generations. Next, based on the complexity, small scale, medium scale, large scale embedded system. So small scale embedded systems usually they are manufactured with 8-bit microprocessors and assembly level language programming, and they are made for only manufactured for only a particular purpose like calculators. So in medium scale embedded systems, the processor capacity has advanced, and memory capacity is also advanced. Instead of using processors, microcontrollers are used and application specific integrated circuits are used, and further they are programmed with high level language. Large scale embedded systems included the advanced application specific integrated circuits, system on chip ICs, and reconfigurable ICs for manufacturing the embedded system. So that is a classification of embedded system. So the major application areas of the embedded system. So application areas of the embedded systems involves consumer electronics, means in your cameras, and household appliances like television, DVD players, washing machines, fridge, micro oven, household appliances. For example, in case of your washing machine, if you consider, it is given with an electronic panel to select the type of the cloth, and the duration. Okay, and it is also speed of the that is speed can also be selected. In fridge, we can select the cooling levels. So must be very much colder or normal. There will be different levels are given. Everything will be controlled by the embedded systems. Next, to home automation security, air conditioners, sprinklers, detection alarms, closed circuit television cameras, fire alarms also uses the embedded system. Automotive industry like anti-braking locking system, engine control, ignition system, automatic navigation systems are the examples of in the automotive industry. For example, if you consider your vehicle, so in your vehicle, the status of the vehicle, like the level of the fuel and the level of the kilometers run, everything will be displayed on a digital display device that is connected to the centralized control system called as embedded system. Next, in telecom. So in telecom, in cellular telephones, example your mobile phones. Mobile phone is also an embedded system. Means it consists of the it consists of the various different types of IO devices like your display device or your microphone. Everything will be that is interfaced to the centralized microcontroller. Next, computer peripherals like printer, scanner, fax machine. So if you consider printer, in printer first asks the settings, means what is the there is number of copies to be printed, xeroxed or printed, and it also asks the type of the paper, So everything will be set by the user. So that user interface that is provided is called as is an embedded system. Means the particular task, for a very particular task, there will be a several number of options will be provided in the printer. So that is because of our embedded system. Computer networking system like network routers, switches, hubs, firewalls. So these are network processors are used in this computer networking system to process the that is your data. Means it will forward the data first. Usually in network computer network system, embedded system, what is the main function of embedded system is to receive the packet, check the address of the packet, destination address of the packet, map that destination address to the corresponding output port and forward that to over the output port. So it is nothing but a centralized microcontroller followed by various IO ports. Okay, from input port it will accept, and on the output port it will send the data. That is forwarding of the data. Next, healthcare like EEG, ECG machines in which the signals are measured and they are displayed on the display, different types of display that is available. That is called EEG and ECG machines also contains the embedded system. Measurement like your digital multimeters, uh, CROs, analyzers, PLC systems use the embedded system for measurement purpose also. Banking, retail, your ATM machine. In ATM machine, what is it has a embedded system inside which asks the first it will accept the card, it will scan the card, then it will ask the password, then it will process the password, then it will dispatch the cash. Like that means everything will be automated using the embedded system. Next, card readers. So in the shopping malls, the barcode readers or smart card readers, all those devices will be there. Each of these devices have very small embedded systems. These are the various application areas. Next, the purpose of the embedded system. Embedded system is mainly used in for the data collection, data communication, data processing, monitoring and control applications. So in data collection case, what happens is, example is camera. It collects the data pictures and converts this to digital form and stores that information. And in data communication, like your network, routers, switches, it will accept the data and forward the data. Data signal processing. In signal processing case, it accepts the signals, real-time signals, and converts that to digital form and processes it and stores or forwards it or represents. Monitoring case like EEG, ECG machines receives the real-time signal and converts it to digital form, and it will display on the display device. And control purpose in industrial applications involves the that is sensors and actuators to sense the particular parameter and control that parameter through the actuators. Means, for example, in case of that is controlling the temperature of the boiler case. So in boilers, the water will be heated. Okay, when the water temperature increases above, the pressure also increases. When pressure increases, the boiler may get blasted. To avoid that, the temperature is continuously monitored, and according to that, the temperature is controlled to control the pressure. Okay, temperature and pressure both are measured, and temperature is controlled by controlling the heating of the boiler to control the pressure. Next, application specific user interface. So we can have a embedded system for any particular purpose. So that is called application specific embedded uh, user interface. So these are the purpose of the embedded system. So next we have embedded system components. In the embedded system components, the first component is the core of the embedded system. The core of the embedded system can be different types, like it can be either it can be a microprocessor, microcontroller, or it can be the digital signal processor, or it can be application specific integrated circuit or system on chip, or that is commercial off the shelf components. Okay, in that first one is microprocessor and microcontroller. So microprocessor And microcontroller, the main difference between microprocessor and microcontrollers is the microprocessor is basically a silicon chip representing central processing unit which is capable of performing arithmetical and logical operation according to predefined instruction. A microcontroller is a highly integrated chip that contains CPU, scratchpad, RAM, special and general purpose register array, on-chip ROM, flash memory, and storage, timer and interrupt control units, and dedicated I/O ports. It is dependent unit. Microprocessor alone cannot be used to implement a particular application. It requires the all the components like memory. It requires the I/O ports. It requires the other devices. Whereas a microcontroller contains all the components required for the. It is a self-contained unit. Means it contains all the components. Most of the time, it's a general purpose design. Microprocessor is a general purpose design, and microcontroller is a application oriented design. Means it depends upon the application. So here microprocessor does not contain IO ports. Microcontroller contain the IO ports. This is microprocessor is targeted for high performance market, and microcontroller is targeted to that is embedded market. Means for particular application. Limited power saving options here includes the lot of power saving options. Microcontrollers are available with the various power saving options. Next, microprocessor and microcontroller follows the two topology, two architectures. One is called RISC and CISC architecture. RISC stands for reduced instruction set computers, and CISC stands for complex instruction set computers. So in reduced instruction set computers, reduced instruction set computers, less number of instructions are there. In CISC, larger number of instructions are there. RISC supports instruction pipelining. In CISC, no instruction pipelining. Here, the RISC in the reduced instruction set computers, the instruction can work only on the registers, whereas in CISC, instructions can work on registers and memory. Operations are performed on registers only. So here operations can be performed with memory. Large number of registers available in RISC, limited number of in CISC because directly memory can be accessed. Programmer needs to write more code to execute the task. Here instructions are like macros, means multiple. If we use one instruction in CISC, many other operations can also be executed. A single fixed line instruction means one instruction is executed